Welcome to HP Tuner's GM Gen 4 Training Part 24. In this video, we're going to be taking a look at our transient fuel. We're going to have a lot to learn, so let's get started. Okay, so let's jump into this video and talk about our transient fuel we're going to be working with in our GM Gen 4 ECMs. So the transient fuel is going to be adding additional fuel above and beyond what's calculated from our air mass registration as we're doing our driving. So under normal steady state conditions, our mass airflow sensor and the speed density calculations are going to be registering the air mass. We'll be delivering the proper amount of fuel to be able to drive our vehicle. Now, when we give rapid throttle changes, we're going to find that we have a rapid manifold pressure change, and then we need to account for that additional air mass. And that's what the transient fuel is going to be used for. It's going to be able to account for that difference in air mass and be able to ascend the appropriate injector pulse width so we have the appropriate amount of fuel that's going to be delivered. We're going to be covering a whole bunch of things here with our transient fuel, from taking a look at the E40 PCMs and then moving into the E38, E67s. They're going to have a little bit of a difference. Then we're going to move into our VCM scanner, set up a custom histogram, and be able to review some data logs and changing our transient fuel and seeing the cause and effect moving through our VCM editor in our calibration file. We're going to have a lot to cover, so let's jump into the video so we can check this out. Okay, so let's get started here. We're going to be taking a look at our transient fuel in our GM Gen 4 ECMs. So first going to take a look here at our E40 ECM. This is the earlier generation Gen 4 ECU. It's going to be a little bit different in the way some of the tables are represent here as we're kind of taking a look at the transient fuel, and we're going to find it's missing one overall multiplying factor that we're going to find is in the later Gen 4 ECU. So we'll cover this first and how to go about dialing in your tables here, and then we'll move into, again, those later ECMs. So let's move into our calibration. This is from a 2005 Pontiac GTO. Let's go into engine here. We're going to move across from our general idle airflow fuel, and then we're going to go all the way from general, oxygen sensors, open loop, power enriched, temp control, cutoff defco, lean fuel saving, and then finally here into transient. So this is going to be where we find the transient fuel. Now the transient fuel is going to allow us to add more injector pulse width or more fuel mass into the engine. As we're driving around, we have a rate of change in our map pressure reading or our throttle reading. And what that's going to do is add an enhancement on top of what's coming here from our normal MAF curve and our speed density table. So as we're driving around, our mass airflow sensor, as it's reading and calibrating that pound per minute or whatever kind of air mass registration we're taking a look at, or if we're going here in our VE table and we're driving around, it's representing the air mass at a particular load in engine RPM. This is going to be representing the steady state air mass entering the motor. It's not going to be accounting for large throttle changes or large load changes with our map sensor reading. So for example, if we're at wide open throttle, we'll be operating in probably these last three columns between 90 and 105 kPa. But if we're part throttle here at say 50 or 60 kPa and we're driving around,